Everyone, welcome to Geoscience Lab. Today we are going to continue with our series of Waec physics practical, and here we are looking at question 1 and the possible questions that we can get from question 1. Now I have some setup on the board, so we're going to read through the setup and see how we can perform the subsequent experiment. Here you have a setup consisting of a retort stand, a spiral or a helical spring, a meter roll, masses N and M, and a knife edge. So let's quickly read through the question. You have been provided with a retort stand, a helical spring, knife edge, meter roll, and other necessary apparatus. Using the diagram above as a guide, as in this diagram, carry out the following instructions. 1. Suspend the meter roll on the knife edge and determine its center of gravity, G. Read and record the value of G. I think we're going to start with that. Okay, let us determine the center of gravity. So let's place my knife edge, then I'll place this on top of the knife edge and try to balance it horizontally. So my knife edge balances at 50.1, 0.2, 0.3. That is my balance point. So I'll record that on the board. So G is equal to 50.3 cm. That's my G. So I'll have to note that throughout the experiment. So let us read through the other parts of the question. Okay, having determined G, we can now read through the question. Suspend the meter roll horizontally on the knife edge at the 95 cm mark. I'm going to read through the question before I start the experiment proper. So I'm going to suspend the knife edge at the 95 cm mark of the meter roll. So we'll note that down. Then we suspend the mass labeled M at the center of gravity with a string. 4. Tie one end of the string at the 10 cm mark of the meter roll. So I'm going to tie one end of the spring with a string. We're going to tie it to the meter roll at the 50 cm mark of the meter roll, and the other end to a retort stand. So the other end of this spring balance will be tied or hung on the retort stand. So you can see the diagram here. It's self-explanatory. Attach the mass labeled N with a string. The mass labeled N with a string on the meter roll 10 cm from the string. So this is at the 10 cm and the string is at the 10 cm. The spiral spring is at the 10 cm mark, while the mass N is 10 cm from there. So that should be what? At the 20 cm mark. So we use this as a guide. Then next, we should add mass. M is equal to what? 40 grams. So that's where we are starting to add values. So I'm going to write a table now, starting with M. So I have M in grams. So we have a column for this. Okay. Pull the meter rule gently downwards through the end close to the spring, that the spiral spring, to set it into vertical oscillation. Determine the time t for 10 complete oscillations. So there is time t here, so I'm going to put t. Now I advise us to take time twice. T1 in seconds. Then we take time again, because the oscillations are very fast, so we need to take averages. So we have T2 in seconds, then T is going to be equal to T1 plus T2 divided by 2, measured in what? Seconds. Then next, evaluate the period T. So there's an evaluation of period there, T, big T is equal to what? Small t divided by number of oscillation 10, also measured in what? Seconds. Then next, also evaluate t squared. So we have to evaluate t squared also. So t squared will be in second squared. So I think these are the values that we have to evaluate. But let's read through. Repeat the procedure for 4 other values of what? M is 50, 60, 70, and what? 80. In each case, determine small t and evaluate t and what? T squared. Tabulate your readings. So let's do that before we come to looking at plotting the graph. So our masses are going to be 40 grams. So I'll take this to 1 decimal point, 40.0. Then I'll take this to 50.0. All of them to 1 decimal point. I have 60.0. I have 70.0. And I have 80.0. So these are the masses we are going to be using to carry out the experiment. Next, let me show us the setup for the experiment. Here is my setup. This is my retort stand. Now this is my spring. I have already tied the rope to it in order for us not to waste much of our time. I believe you can do that. So this is this. Now what you are going to do, you can open up the string a little bit and attach one end to the retort stand. Okay, then this is the mass sealed as N. So I already have a rope tied on this. So I'm going to put it at the 10 cm mark. Okay, this is my knife edge on this edge. And I have my slotted masses all around here. So let's see. So this is placed there. So I can take this through this other side and place it at the center of gravity. My center of gravity that I measured was at 50.3. So I'm going to place it at 50.3. 1, 2, 3. So I've placed it at 50.3. Then this, I'm going to hang this at the 90 cm mark. So this is at the 90 cm mark. This should be at the 20 cm mark. Okay, we can fix that back. This should be at the 20 cm mark. And this will be at the 10 cm mark. Not to worry, we are going to fix all of that back and arrange all of this. So this is at the 10 cm mark. Let me adjust this to the 10 cm mark. All you have to do is just to adjust. So I have adjusted this to the 10 cm mark. Let me, okay. In order for us to avoid that, so let me take this out of this place and put it here. Okay. 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 So this is at the 10 cm mark. And this has adjusted a bit, so I have to adjust this to the 90 cm mark. So this is at the 90 cm mark, 20 cm mark. So I have to put this load here. Okay. Let me adjust this. You see that this is stretching. So I have to push this forward a bit. So that it can be vertical. So this is what is required. Then the instruction is that we should put a mass of 40 grams So it's not that difficult. You look for slotted masses. I have 2 slotted masses here, 20 grams each. So I'll attach them and add them to this. And I add this to this. This is 40. So I need to take 20 oscillation. I'll just display from here and take 20 oscillation. This is my stopwatch. It's an analog stopwatch. You can get a digital stopwatch. So I'm going to set this into vertical oscillation from here. Let's see. So you see that it is dancing. I have not started counting. You can allow it to settle down when you are ready for counting before you start counting. So let me go. Let me just display this again so that I have an ample time to take it. So let's see. I want to be in rhythm with this. So let's go. So let's set again. So let's go. Okay, 1, 2, go. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my time is 7.1 second. 7.1 second. That is my time here. So I'm going to record it for T1. So I'm going to record this to 2 decimal places, 7.10. Because if you are using a digital clock, you are going to be having decimal values to 2 decimal places. So let's take this to 2 decimal. You can take it to 1 decimal place. It's okay as long as everything is uniform. So let's take that again. I'm going to take it again for T2. So let me depress it. Now you see that I'm using 10 oscillations here. So it can be 20 oscillations. You do it the same way. So I'm using 10 oscillations. In fact, you can get 10 oscillations and multiply it by 2 to get 20 oscillations. So let me go for the next one again. So let's go again. Let me go. 1, 2, ready, go. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this time around, I have 6.2. So it's 6.20. Let's just take it and we can evaluate later on. Next, we have to put a mass of 50 grams. So I can remove all of this. The 4 grams. And I'll place a mass of 50 grams here. So I have a mass of 50 grams. Now let's set this into oscillations again. 1, 2, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here I have 6.4 seconds. 6.40 seconds. Okay, I will set that again. Let me go again. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 6.4 seconds. 6.40 seconds. Now you see that this is it. Let me go back and take this again. I'll take this again and see what I'm going to have for that. So let me add the 4 TCM mask again. $40 mass rather. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this time around I have 5.50. 5.50. So I think this is better one. It's closer to the other one. So let's go to the next one, 60 gram. So for 60 gram, I have another 20 gram mass. Just add it to this to make it 60 grams. So let's set it to vibration. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here I have 6.60. 6.60. So I can retake that again. Let me set it to oscillation again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. here I have 7.0. 7.00. So we take the average, that is the essence of doing it twice. You see that I'm having discrepancy in my reading because the thing is very fast. So let's go to 70. So we can add a 50 gram mass and a 20 gram mass to get 70. So I have 20 here. I'm going to add this to it. So that is 70. Okay. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my time here is 7.20. 7.20. So let me take that again. Reset my clock. Take that again. Let's go. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my time here is 7.60. 7.60. Okay. So the last one is 80. So let me just add. This is 20, 40, 60, 60. Now add another one to make it 80. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 7.40, 7.30, 7.30. Let me take this again. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have exactly 7.10. So that is the readings. So let's take the averages. So we'll just add this and this together and divide by 2. So I have 5.50 plus 6.20. That's equal to 11.7 divided by 2. That's 5.85. 5.85. Okay, for this, you have 6.40 plus 0 divided by that gives us 6.40. So that's the evaluation. Now to get this, we'll divide this by 10. So that gives us 0.585. We'll divide this by 10, we'll get 0.640, 3 decimal places, everything. If this one is in 3 decimal, this one must also be in 3 decimal places. 6 divided by 10. So we can evaluate all this t squared. So we have 0.585 squared is equal to 0.342. 0.342 to 3 decimal places. Okay, so we are done with the setup. We can read through the other instructions. Okay, we have evaluated all of our value. Next, we are to plot a graph of t squared on the vertical axis against n on the horizontal axis. Determine the slope s of the graph. Evaluate k is equal to 4 pi squared over s and take pi is equal to 3.14. State 2 precautions taken to ensure accurate results. So I'm going to plot this on the graph and let's see how the graph looks like. Now I want to draw to your notice that this, what you have here, is as a result of work from all of us. I was the one that created these questions because we don't have this type of questions anywhere on the past questions. We don't have this on the past questions. So we just came up with this. Maybe the question that will come from Waec may be different entirely from this, but we hope that what we should be expecting should be close to something like this. Okay, so let's plot the graph and see how it looks like. To draw the graph, I have shortened the table to this format here. Now, to make this graph, so what we need is to plot t squared against m in gram. So to make this graph very easy for us, what I'm going to do, I'm going to write these numbers in form of standard form. So I'm going to write this as t squared in second square as times 10 raised to power, or you can put this one here, minus 3 in second squared. How am I doing that? I've just moved this 1, 2, 3. So now you see that I'm going to have 342 times 10 raised to power. So there's no times 10 to the power minus 3 again because I already have it here. So this is going to be 410. Just move 1, 2, 3. So I have 410. Then this is going to be 462. This is going to be 518. And this one is going to be 518 also. So these readings are the same. I am sure that it was because of some errors in my reading, but notwithstanding, we can still figure that out from the question. So what we'll now do is this. So we are putting this on the vertical axis. So you see that our values are of hundreds. So we can plot a graph by starting this. We just ignore this. So we can start from 0, 0 and move down to, this is 518. So we can move down to 600. So on this part here, if we have 600 here, or let me start from here. If I have 0 here, this is my 0 mark. If I have my 0 mark here, because I want to use almost all the part of this graph. So if this is my, let's say this is my 0 mark, I have 100, 200, 300, 400, 600. It looks small. Let's see if we can push it up. So let's say 100, 200, 400, 500, 600. So that will be enough. So because I want to stretch the graph. So let me see. So if I take my 600 here, 500, 400, 300, 200, 100. So let me draw my vertical, the horizontal axis through this point. So I'll draw my vertical axis through this other point here. So I'm drawing this with a pen so that it will be clear for you to see. So you do not draw with a pen on this. You do not write with a pen on this. Do anything with a pen on this. Anything you have to do, you do it with a pencil. So let me include on this side. This is my t squared times 10 raised to power minus 3 second squared. That's what I'm plotting here. These values here. So I'm ignoring this and putting it to make my graph to be very easy. So let's go this way. So this is going to be 100, 200, 300, 400, okay, 500. This is definitely going to be 550 here. So it will go enough because the very highest value here is 518, which is between 500 and 580. So that's okay. So we can go with that. Or if that's the case, you can come to this middle and make this to be 50 so that you can include this to 550. So this is 50. So this is 150. This is 250. This is 350. And this is 450. So from here you can see that your scale, you're going to put the scale, your scale on the t-square axis. So you put t-square axis. Please do not write y-axis. It's t-square axis. So your scale is, each of these from here to here is 2 cm. So you have 2 cm to 50 times, because there's 10 raised to the power minus 3 here, times 10 raised to the power minus 3 what? Seconds squared. So that's the scale on that axis. Now let's take this scale for this. This will be very simple. So we have from 40 to 80. So we can start from 10. So we have 10, 20, 30, 40, 50, 60, 70, 80, and let's extend that to what? 90. So on this side here, you are going to put the unit, the quantity that we are placing here. That's mass in what? Grams. You can put it on this side. You can also put it on there. Then don't forget to write the title. So on this now, you can see that we have 2 cm to what? 10 grams. Please do not use unit, because the unit here is indicator, which is gram. So on the m axis, we have 2 cm to 10 grams. So I said, so you now have to write the title of the graph. The title of the graph is the graph of t square in second square against mass m in what? Grams. We're done with that. Now let us read out the point. Now there is something that I normally do that makes your graph very easy. You can easily read the horizontal axis from here. The values on the horizontal axis can easily be read. So to make this one easy to be read, I will choose a scale like this. I'm going to choose a scale like this. This is 50. So 50 divided, now look at this. The quantity that occupies here is 50, but the number of small squares is 10. So when you divide 50 by 10, that gives you what? 5. So it means that each of these small square is 5. So from there, you can read your values of this. But what I normally do is this. To make my work easy, if I want to read 342 off this place, 342 off this graph, what I'm just going to do is this. I'll just take my calculator and I'll depress 342. Then I'll divide it by this. This is my scale factor. I'll just divide it by 5. So that gives me 68.4. What it means is that because I'm plotting against 40, I'll just go to 40. I'll just count 68 small boxes upward. Of course, you know this is 10, 20, 30, 40, 50, 60. So I have 61, 62, 63, 64, 65, 66, 67, 68. So this is 300 and what? Just put a dot there and circle it. Now if I want to plot 410 against 50, I'll go to 50. I'll go to 50 and I'll press 410 divided by 5 again. So that's going to give me 82. So it means that from here I'm going 82 places upward. So this is 10, 20, 30, 40, 50, 60, 70, 80, 81, 82. So I'll put a dot here and I'll circle it. As easy as that. I won't be stressing myself counting. Just divide and count the number of small squares upward. Now I want to go 462 against 60. So I'll do 462 again. 462 divided by 5. That's going to give me 92.4. So use your discretion to put your point. So on 60, I'll go 92.4. So this is 60. I'll go 10, 20, 30, 40, 50, 60, 70, 80, 90, 91, 92. 92.4 should be between 92 and 3. So I'm 93. So I'll just put a dot in the middle and circle it. And the graph is making sense. You can see that there is sense coming out of the graph. So the next one is to do 518 divided by 5 again. So I have 103.5. So from 70, okay, we are plotting 70. From 70, I will go 103 103.6 places upward. So I've got 103. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 101, 102, 103, 103.6 is between 103 and 104. So I'll put it at the middle. Put it at the middle there and circle it. Then we have this other one, 80. In fact, on my graph here, they are exactly the same. So like I said, this point and this, so I drew this here. So I drew my line of best fit across this point, and this, and I omitted this and this one downward. So to get your slope, what you have to do is to draw a straight line. It's a big triangle. Draw a big triangle. I like to use corner point, so I can use this. Let's say this. Use a ruler to draw that. To draw a straight line through this. Draw it to any length as long as it is what? That of big size. So let me use this point. Just use a ruler to draw this. So after you have drawn your line of best fit, so that's what you have to do. So the slope of this is going to be this. Now, you know, when I was taking this upward, I had to what? Divide by 5. Well, this is what I'm going to do now. This is what I'm going to do. You know that our scale factor is 5. So this is what I'm going to do. So from this point, count upward. So this is 0. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 101, 102, 103, 104. So it is 104 that it touches this. So you are going to do this. 104, multiply it by 5. When you multiply 104 by 5, that gives you 520. So my top point here is 520. No stress. You are not stressing yourself. So S is equal to 520 minus, then come to this down point here. This point here, that is exactly what? 200. You can see it from here. So write it minus 200. Then put it in a bracket. When you put it in a bracket, remember that this, whatever we have here, we are multiplying by 10 raised to power minus 3. So we have times 10 raised to power minus 3 divided by, so you are going to read this other point down now. Read this point downward, this place, which is what? 70. This is 70. So you write 70. So the unit of this is second square minus, so this other point here, you trace it down. This is 10. So this is 11, 12, 13, 14, 14.5. 14.5. And this is also in what? Grams. So let's work the top. So S is going to be equal to, I'll just do 520 minus 200. That's equal to 320. 320 times 10 raised to power minus 3 divided by 70 minus 14.5. That's equal to 55.5. So I will divide this. On dividing this, X is equal to 320 exponential minus, that's raised to power minus 3 divided by 550. So that gives me 5.76. 5.76. This is second square per gram. So that is my X. Now, we are also told to evaluate K equals 4 pi square over S, taking pi to be 3.14. So let me evaluate my K here. K is equal to 4 pi squared all over the slope S. So that's going to give us 4 times 3.14 squared divided by, my slope is 5.76. So let me just multiply this as, okay, my slope is actually 5.77 to 2 decimal places. I'll meter that, 77. So on doing this, I'm going to have 4 times 3.14 squared divided by 5.77. So that's equal to 6.8. So my K is equal to 6.84. Now the unit of this was second square per gram. So it's going to be gram
per second squared. So that's the value for my what? K. So this is the value for my what? K.